Welcome back. Here we are, ready to start our scanning phase. We have covered the information gathering, which was first phase of penetration testing, and now we will proceed with the second stage by scanning our target and trying to get even more information about it. Now, the difference between information gathering and scanning is that scanning is performed on a much deeper level. And also, while in the first phase we gathered all kinds of information such as emails, phone numbers and a bunch of other things, in the scanning we are mainly focused on technology side. So we want to find out as much as we can about our target's technical aspect. We're going to talk about in just a second as to what exactly are we looking for in this stage and what are all the goals of this stage. But first, you could be wondering, what are we going to scan? Since remember that scanning is something that we are not allowed to do on any target that we want. Don't worry, for this stage and any future stage from now on, we're going to be using vulnerable virtual machines. There are lots of paid vulnerable virtual machines that you can buy and test on, but for this course I will be showing the free ones. So all of us can download them, install them and then try to hack them. All of these virtual machines are going to be running some outdated vulnerable software that we will be able to exploit in the third stage, and they will also require very little hardware power. So all of us will be able to run them while also running Kali Linux. And keep in mind that penetration testing process will look exactly like it would look in real world if you were to test some website or some network. The only difference is that right now we know that these machines are vulnerable since I just told you, and in real world you wouldn't essentially know that before testing them. However, just knowing they are vulnerable doesn't really help us, as we need to figure out in what way are they vulnerable and how can we take advantage of that. Scanning will help us with this. We will be using our Kali Linux machine to scan these machines. And by scanning these machines, what I really mean is we're going to directly exchange packets with our target, and once that target sends packets back to us, hopefully it will discover something about the target machine that we will find useful. And what we will be sending to the target are TCP and UDP packets. TCP and UDP are just protocols that are used for sending bits of data, also known as packets. And we will discuss them in a little more detail in the next video. For now, just think of them as different communication protocols that will allow us to get information from our target. I keep talking about information and scanning and all of that without actually explaining what do I mean by scanning and getting information. What are the goals of this? What are we looking for exactly? Well, we're looking for open ports. And I don't mean USB ports or some physical ports, I mean we're looking for virtual open ports that every machine has, and it uses them to host their software and communicate with other machines over internet. For example, you watching this over internet on a website means that the machine that's hosting this website has port 80 open. Why port 80? Well, port 80 is used to host a web server. It is used for HTTP, and it's also known as HTTP port. So every time you visit a website, you are essentially making a connection to that machine hosting that website on port 80 or on port 443, since port 80 is used for HTTP and port 443 is used for HTTPS. And HTTPS is just a secure version of HTTP. These are the two most usual ports that target that you're scanning externally will have open. And by externally scanning, I mean that you're scanning it while not being in the same network as the target. An example would be you scanning some website from your home. And a port that could sometimes be open if you're scanning internally, which means either scanning machines on your network or you're performing network penetration testing inside of some company, you could, for example, find port 21 to be open. This is an FTP port and it's used for file transferring. FTP stands for File Transfer Protocol. These are just two of the ports and there are a lot of them. You could, for example, have port 22 open, which is SSH port, or secure shell port. It is used to log into the target machine and execute commands on it remotely. We could also have, for example, port 53 open, which is DNS port, or we could have port 25 open, which is SMTP port. So there are a lot of ports. Matter of fact, every machine has 65,535 ports for both TCP and UDP. And if there is just one open port with one vulnerable software running on that open port, then that target is vulnerable and it could be exploited. Now, the highest secured machines are the ones that have all ports closed. These are usually your home devices, such as laptops or computers that you use just for browsing online or playing video games or something. They don't need to be hosting any software since they are not a server that someone will connect to for a certain service. They're just home devices that you use. But websites, for example, must have port 80 or port 443 open since they are hosting a web page there. Also in companies, their machines could have some port open. Maybe they use that port on all their machines within that company to internally transfer files between different machines. It could be anything basically. Now, the problem occurs if that software they use on their open ports is outdated and has a vulnerability. Then our job as a hacker is to scan that machine for open ports and exploit that machine through that vulnerable software running on that open port. But the goal for now in the scanning section is only to scan the target for the open ports. Then we want to discover what software are they running on those open ports. And we want to go as deep as discovering what version of software is on that open port. Are you ready? We're going to be covering a lot in this section, and in this section we will cover one of the most important tools that a hacker must master. That tool is called Nmap. Let's dive into scanning. Welcome back. Before we proceed with scanning, I just want to give a basic overview of TCP and UDP protocol for anyone that is encountering it for the first time. We already mentioned what TCP and UDP are. They are two different protocols used for sending bits of data, or also known as packets. TCP and UDP are not the only protocols that are out there, however, they are the most widely used ones. Let's talk about TCP first. So TCP stands for Transmission Control Protocol, and it is the most commonly used protocol on the internet. When you load a web page, your computer is sending TCP packets to the web server address, asking it to send the web page to you. Then the web server responds by sending a stream of TCP packets, which your web browser stitches together to form the web page that you see. The same happens once you, for example, click on a link or sign in or post a comment. Your web browser sends TCP packets to the web server, and the server sends TCP packets back. However, TCP is not a one-way communication. The remote system sends packets back to acknowledge that it received your packets. So TCP is based on three-way handshake. And as the name says, three-way handshake is consisted out of 3 steps. First one is SYN. In this step, the client wants to establish a connection with the server, so it sends a segment with SYN, and what SYN stands for is Synchronize Sequence Number, which informs server that client wants to start communication and with what sequence number it starts the segments with. After the SYN step comes the SYN-ACK, which is the second step, and in this step, the server responds to the client request with SYN-ACK signal bits set. ACK signifies the responsive segment it received, and SYN is the same from the first step. It signifies with what sequence number it is going to start the segments with. In the third and final step, which is just ACK, in this step, the client acknowledges the responsive server, and they both establish a reliable connection with which they will start the actual data transfer. This is just an example of TCP communication establishing between a client and a server. Once the data transfer starts, TCP guarantees the receiver will get the packets in order by numbering them. Then the server sends messages back to the sender saying it received the messages or packets. If the sender does not get the correct response, it will resend the packets to ensure the server got the packets. All of those packets are also checked for errors. So TCP is all about reliability. Packets sent with TCP are tracked so no data is lost or corrupted in transit. That's why once you download a file, for example over the internet, your file is working once you run it on your machine, because it is being transferred with TCP, so all of the packets will reach their destination without any errors. UDP, on the other hand, stands for User Datagram Protocol. A datagram is the same thing as a packet of information, and UDP protocol works similarly to TCP, but it throws all the error checking stuff out. That's why UDP is much faster. It is used when speed is desirable and error correction is not necessary. For example, UDP is frequently used for live broadcasts and online games. That's why UDP doesn't really care whether packets received its destination, and it will not resend a packet if it didn't reach the other part. It will just continue sending other packets. You cannot ask for those missing packets again with UDP, and these are just the basics behind two most known protocols for communication. Even though many of you probably knew this already, it is good to have a refresher since we're going to need this knowledge once performing scanning. See you in the next video. Remember I told you that we must have vulnerable machines that we can scan? And before we actually proceed to performing scanning and covering different tools that we will use, let us first see where we can get a vulnerable machine and how we can install it. And trust me, it is pretty easy. So just type top 10 vulnerable machines and you will see this Rapid7 link that says 10 places to find vulnerable machines for your lab. Click on that link, and down here, if I scroll all the way down, I should see a list of 10 different vulnerable machines that we can use as a hacker to practice our skills. And for this section, we're going to be going with the first one. So the name of it is Metasploitable. Click on it, and it will route you to another page of Rapid7 website, and it will tell you Metasploitable virtual machine to test. You can read through this if you want, as it tells you some of the information about the Metasploitable. But what's the most important part is down here. In order to download this machine, you must fill in this information. Now it is up to you what information you will fill, right here. But as soon as you fill all of this, you can click on Submit, and it will lead you to a page where you can download Metasploitable. Up here, it tells us that Metasploitable is free to use after we fill out the form. So this is something that you must do in order to download it from the official website. And after you finish downloading it, you should finish up with a file that looks something like this. So Metasploitable linux.zip. You want to extract this file. As you can see, I have already extracted it, and you should see these files right here. This VMDK file is our hard disk that we're going to use in a virtual machine. So let's see how we can install it. Go open up your VirtualBox, and we want to be creating a new virtual machine. We already know how to do that. Click on this new button right here, and it will ask us for the name of virtual machine and the operating system. You can name it anything you want. I will just name it Metasploitable 2. And the reason why I'm naming it 2 is because I already have it installed right here, so the names differ. In the type of operating system, you want to select Linux. And in the version of operating system, you want to scroll all the way down and select Other Linux 64-bit. Once you got these settings ready, click on Next. And this is what I talked about. These virtual machines will use very little hardware resources from your physical machine. That's why for this virtual machine, for the Metasploitable, we can leave 512 megabytes of RAM. It is more than enough for this machine to run. It will even work if you lower it to 256 megabytes of RAM. But 512 is recommended, so let us leave it on 512, and if you don't have this much RAM to use, you can leave it on 256. Then proceed on Next. And in this step, instead of creating a virtual hard disk now, we want to use an existing virtual hard disk. Once you select this option, click on this icon right here and click on Add. Then find your virtual hard disk wherever you got Metasploitable downloaded. For example, I got it on my desktop right here. Here it is. Find this VMDK file, select it, and then select it right here again and click on Choose. Once you do that, you can click on Create. And this is pretty much it. We got our Metasploitable created. All we are left to do right now are two things. The first thing is navigate to Settings, go to the Network Settings, and switch from NAT to Bridge Adapter, the same thing we did with our Kali Linux machine. Then choose your adapter and click on OK. This will just make our Metasploitable 2 IP address belong to the IP range of our network. Once you do that, click on Start. And this will start the process of installing Metasploitable for you. Unlike in Kali Linux, right here, you don't need to do anything. This will install machine on its own, and it will take about a minute or two, maybe even less. So at the end, after this finishes, it should prompt us with a login. And you will notice that this machine doesn't have a desktop or anything else, it is a command line machine. That means we can only navigate through this machine using commands. And those commands are simply terminal commands. So just picture this as one big terminal. As we can see, the installation has finished, and down here we got Metasploitable login. And if you read through this website, right here, if you read through this paragraph, it tells us right here that the Metasploitable login is msfadmin and the password is also msfadmin. So let's try it out. Go to our machine, type msfadmin, and under password, again msfadmin. And here we are. We managed to log into our Metasploitable. Just to check our network, type ivconfig, and it will tell me that my IP address is 192.168.1.3. That is because I set it to be over bridged adapter. And if we try to ping Google, for example, it will work. So our machine is set up and it is ready to be scanned and attacked. You see, this was pretty simple to do, and in the next video, we are ready to start our scanning process. See you there. Okay, so we know what scanning is. We also created our virtual machine that is vulnerable, and now we are ready to see what information can we get by scanning that machine. But before we scan a single machine to discover open ports, we must first discover what machines we got on our network. So the first part of scanning a network is to figure out how many hosts you have active and what are their IP addresses. In this case, we are going to act as if we got a task to scan our home network. And we want to discover vulnerable machines within our home network. So let's start by seeing how many hosts we got active first. There are many ways that we can go about doing this. Since I know that all the possible hosts for my network must go in range from 192.168.1.1 to 192.168.1.255. Since my IP address starts with these three first numbers, let me just type the password, and here it is, 192.168.1. This is the part that doesn't change. And to scan all 254 hosts inside of my network, I can just go and ping each and every one of them, and see whether they respond to our pinging or not. If they respond, they are online. If not, they are offline. But what if I had to test more than one network? What if I had 10 more networks, besides this one, that I needed to test? Am I about to try to ping every possible host from all those networks? Of course not. That's why we're going to use different tools to perform this much faster. Let us try with the first tool called ARP. Now, ARP is a tool in Kali Linux, but it is also a packet. ARP packets are used in discovering hosts on the network, but more about them later on once we get to the man in the middle section. For now, just remember that they are packets for discovering hosts. Before we use this ARP tool, make sure your Metasploitable is started up. And in case you got some other devices that you can connect to the internet, connect them just so we can get various output and try to figure out which IP address belongs to which host. Now, our ARP tool works based on those ARP packets that I mentioned. So if I type ARP --help and press enter, it will tell me command not found. Now this is because I must run the tool with sudo privileges. So sudo ARP --help, and here is the tool. It doesn't have too many options. We got -a, which displays all hosts in alternative BSD style, -e, display all hosts in default Linux style, and these options down here are not something that we're interested in. All we want to do is use this -a option. So if I go down here, clear the screen, and type sudo ARP -a, it will tell me it only discovered my router. But why is that? I got my Metasploitable running, also got my laptop running, so it should be discovering other hosts as well. Sometimes we must ping a host first before it appears right here, since this information is being read from our ARP tables. So if I, for example, try to ping my Metasploitable, it will get responses back, and if I run ARP -a again, now we will see that we got an entry for the Metasploitable inside of our ARP tables. So this tool doesn't seem to be that good for discovering hosts. Sometimes it will have all the hosts available since you already communicated with them before, but sometimes it seems that we must ping the host first before it shows them. That's why a much better option is a tool called netdiscover. To run netdiscover, we can simply type sudo netdiscover inside of your terminal, press enter, and this tool will find all of the available devices on your network on its own. You don't have to ping anything, you don't have to communicate with anything, you can just leave this tool to run and it will find all the devices on your network. So right here it managed to find 5 of them. We can see up here that it is still scanning, and it is just scanning different subnets, so it already finished mine, and you can control C this if you already see the result, since this will scan all the usual subnets that occur in a network. Right here we see that we captured 5 ARP packets, and there are ARP requests and ARP replies, but once again more about that later. This just means that we managed to discover 5 hosts using these packets, and these are those 5 hosts. Let me control C this, since it won't really manage to find any more hosts. And right here we got their IP addresses, their MAC addresses, and their MAC vendor name or host name. So right here, I know that this is my Metasploitable, which is this one. This 192.168.1.7 is my host machine or my physical machine that I'm running my Kali Linux on. These 2 down here are 2 laptops, I believe. And this right here is my router. And how do I know that this is my router? Well, usually routers start with the first number. Either it will be something like .0 or .1. And just so you can be sure which IP address is your router, you can type the command netstat-nr, and under this gateway column, we should see the IP address of the router. So you can see they do match. The next step would be to go about scanning each and every one of them. And for this, we're going to be scanning our Metasploitable, and you can also scan your home machines just for even more practice. See you in the next video. It is time to start with the first big tool that is essential for ethical hackers. That tool is called Nmap. We're going to cover a lot of things inside of it, and unlike all the other tools that we covered by now, which you might or might not use in penetration tests, this is a tool that you will almost always use without any doubt. So what is Nmap? Nmap is a network mapper. It is a free and open source network scanner, and it is used to discover hosts and services on a computer network by sending packets and analyzing responses. It has a lot of different options, and we're going to check them out in the next few videos. For now, let us just see how we can start Nmap and run a basic scan. First thing, make sure your Metasploitable is up and running, and also if you got any other devices in your home network, turn them on just so we can scan them as well. Okay, let us see how we can run Nmap and what options do we get with Nmap. Just like all the other tools, we can get the Nmap help menu by only specifying Nmap in terminal or specifying Nmap --help. And you will see right away we get a lot of options right here. And this right here is just a short help menu. We will see the longer menu once we start experimenting with these options right here. But for now, we're only interested in running Nmap with just a basic scan. So for basic scan, all we need to do is specify an IP address. If we go to the help menu and you scroll all the way to the top, we should see target specification right here. It tells us that we can provide a host name, an IP address, or a network for scanning. And below that we got some of the examples of what we can specify with Nmap and what is the syntax for specifying hosts. We can also read our targets from a list by specifying option -il. And if we want, we can exclude some hosts that we don't want to scan by specifying --exclude option. For the first time, let us get an IP address from our Metasploitable and let's scan it to see what results we get for scanning one IP address. We already saw how we can get Metasploitable IP address. You can either run netdiscover to see all the online hosts, or if you don't want to bother, you can just go to Metasploitable right here and type ifconfig. I can see that the IP address of my Metasploitable is 192.168.1.6, so that is the IP address that I will use. Let's run our first Nmap scan. If I type Nmap and just 192.168.1.6 and press enter, wow, this finished pretty fast. But don't get used to it. The only reason that this scan finished so fast is because the target is on my home network. True Nmap scans can sometimes take hours to finish, depending on where your target is, how many ports they have open, are they protected by firewall, and many other things that we are also going to cover. But for now, this is the response for our Metasploitable with our basic scan. So it tells us that host is up, it tells us which open ports it has, we get the exact number of which ports are open on the target machine, and right here we can notice that there are a lot of ports that are open. That is because Metasploitable is running a lot of services. Nmap also tells you, besides the port that is opened, which service is running on that open port, and this is this third column. So we can see that port 21 is open and it is running FTP, which we already know that it's file transfer protocol. We got port 22 to be open, and that port is for secure shell. We got port 80 that is opened, and that is an HTTP port, and this could mean that our Metasploitable could be hosting a web page. We can check this out if we type the IP address of our Metasploitable inside of our Firefox. So let's go up here, open up our Firefox. And if I go up here and type 192.168.1.6, press enter, this will automatically go and try to connect to the port 80, and indeed it is hosting a web page. But more about this web page later on in the course, as it holds a bunch of vulnerabilities which we will cover. For now, let us just see what other things we got with our Nmap. So besides these known ports that we got right here, we also discovered bunch of other ports hosting different services, and some of them could be vulnerable. We also see this right here that says not shown 977 closed ports. But wait a second, I said that there are over 65,000 ports. Why does it say that it didn't show only 977 ports? Or it shows that only 977 ports are closed. That is because Nmap by default scans most known 1,000 ports. It doesn't scan all 65,000. We can tell it to scan all 65,000, which we will see later on, but in most cases it is not necessary. Okay, cool. Our first Nmap scan gave us some results. And all of these results from our scans, you would write down in a report in a real penetration test. Now that we know how we can scan one IP address, let us see how we can scan a range of IP addresses. Let's say we want to scan our entire network, and for this once again you must know your subnet of your network or your network's IP range. We talked about this earlier. For me it is from 192.168.1.1 up to 192.168.1.255. So we can specify this in two different ways. We can type nmap 192.168.1.1-255, or we can type it like this, 192.168.1.1/24. And if you're new to subnetting, you can think of this /24 as something that says first 3 octets are not changeable. And by first 3 octets I mean first 3 numbers, which leaves us with only last octet or last number that will be changeable inside of our IP range. So let's scan it. If I press enter. Now this scan right here might take a little bit more time, since it is not only scanning one host, it is scanning multiple hosts. And even though it's scanning multiple hosts, it finished relatively fast because it is scanning my own network. Let us read the results. So this right here are the results for the Metasploitable, as we can see by the IP address, and we got the same results as before, which ports are open and what services are they running. Down here we get that it scanned 256 IP addresses and 3 hosts are up. Let's see what other 2 hosts are up besides our Metasploitable. We got a device with the IP address of 192.168.1.4, and it says right here all 1000 scanned ports on this device are closed. And you remember when I told you that this is the more secure version, since right now we cannot connect to any one of these ports. And this is probably some home device, possibly my laptop. It has all 1000 scanned ports closed because it doesn't host any service to other machines. And the last device that we got is my router. We got its IP address and we also got which ports it has open. So it has port 22 for SSH, port 23 for Telnet, port 53 for the domain, port 80 and port 443 for HTTP and HTTPS, and this port right here that says service unknown. This is because Nmap couldn't figure out what service is running on this open port. Okay, great. For now we performed basic Nmap scan without adding any additional options to it. And with this, we managed to discover open ports on our target machines. That is good for the start. In the next video, we will see what else can we discover using Nmap and what other cool options it has. It is time we discuss different scan types that we can do with Nmap. Now, Nmap is a huge tool, and it offers many different types of scans that we can perform, and we will be covering just some since there are a lot of them. However, at the end of this video, I will give you a really good tip as to how you can really master the Nmap tool. Talking about different scans doesn't necessarily mean that we will get different results. Matter of fact, many of these different scans will give us the same result. And in this video, I'm going to explain exactly what the differences are between certain scans. To fully understand this, you will need a background knowledge on TCP and UDP. So, in case you didn't watch the short video I made on TCP and UDP, make sure to watch it before covering this. Let's start with the first type of scan, and that scan is called TCP SYN scan. Let me open the terminal. The command that we must run is nmap-ss, and then we're going to be scanning Metasploitable in this video, since that is the machine that we are attacking. So the IP address of my Metasploitable is 192.168.1.6, and this -ss is TCP SYN scan. SYN scan is probably the most popular scan in Nmap. It can be performed quickly, scanning thousands of ports per second on networks that aren't protected by a firewall. And the reason why it is called a SYN scan is because it never really opens a full TCP connection. You only perform the first step of three-way handshake, which is sending SYN. And the way it works is, if the target sends SYN-ACK back for a certain port, that indicates that that port is listening or it is open. Target can also send something called RST, which stands for reset, which would indicate that the port is closed. In case it doesn't give any response back after several tries, port will be marked as filtered. And filtered is just another state of ports that happens once Nmap cannot determine whether a certain port is open or closed. The filtered state could happen if port is, for example, protected by some filtering or a firewall. And now that we know exactly how TCP SYN-SCAN works, let's test it out on our Metasploitable. There is one thing with this command. If I try to run it, it will not work. It will tell me, you requested a scan type which requires root privileges. And the reason this requires root privileges is because we're only sending one part of three-way handshake and telling our machine that we do not want to respond to a SYN-ACK bitset in case it is sent back from the target. That requires root privileges. So we must run this with sudo nmap-ss, and then let's type in our password. And we will notice it gives us the results of ports that are open very fast. And it is also very important and satisfying once we know how certain scan type works. Once again, it sends only the SYN and waits for a SYN-ACK or RST, and it never establishes a full TCP connection. Let us check out the result. So we got these ports open, and we also got what service is running on those open ports. Now, here's the time that it took, and we're going to compare this with different scans. And the reason it finished this fast is, once again, it doesn't establish a connection. Compared to this SYN scan that we just performed, we also got something called TCP Connect Scan, or also labeled as -st. So in order to run this, we can just change this command from -ss to -st. And you will see all of these options if you run the help menu of Nmap. What's interesting about this is that it does not require sudo privileges. And the reason it does not require is because it performs a normal TCP three-way handshake connection. So the only difference between this and previous scan is that TCP Connect Scan establishes a full connection. The important part here that you should remember is that this scan will leave much more trace that you performed an Nmap scan on the target machine, and it is easily detected. That's why once you can run Nmap as root, usually SYN-SCAN will be a better option than the TCP Connect Scan. Nonetheless, let's test this one out so we can remove sudo, as it does not require root privileges. And you will see it also finishes relatively fast. The output will be exactly the same as with the SYN-SCAN, but sometimes it could take a little bit longer than the SYN-SCAN since it is performing a full TCP connection. And even though we got the exact same result, which are just the open ports and the services that they run, now we know how both of these scans work. And now you know that, for example, this scan is much more detectable than the SYN-SCAN. Or you can say that it just makes more noise on target machine. The last scan that we're going to cover, and keep in mind these are just some of the scans, and I will show you where you can find the rest of them and possibly test them out if you want to. But the next scan that I'm going to cover is pretty unpopular, and that is the -su scan, or also known as UDP scan. The reason why it's unpopular is because many services on the internet run over TCP protocol, as we already know. Since UDP scanning is much slower than TCP scanning and more difficult, sometimes when people are developing security for their ports, they ignore the UDP ports. And this results in a mistake, as there are a lot of exploitable UDP services, and we should never ignore this scan just because it takes time. Let us test it out. This also will require sudo privileges, so let us type sudo nmap-su for the UDP scan and specify the IP address of Metasploitable. You will notice this scan will take time. You can check at how much % it is currently at by pressing the upper arrow key. So if I press upper arrow key, down here it will tell me it is currently at 3%. And I'm just going to leave this running while I show you the cool tip for the Nmap. So remember this, the key to learning Nmap in great details is not in reading its help menu, but in reading its manual. And to open the Nmap manual, you can open your terminal and type manual Nmap. And let me do this in a second terminal. So I will open it up, type man, and then Nmap. This man right here is shortened for manual. Press enter. In this file, it explains every Nmap option in great detail. Let us find different scan types that also exist, since we didn't really cover every one of them. Let's scroll all the way down to different Nmap scans. And as we're scrolling, you will see that we are passing the actual help menu that we get outputted once we run the -- help. And below this help menu, it explains every option in great details. And as I'm scrolling, I came to this part, which says port scanning basics, and here are the 6 port states recognized by Nmap. And this is good to read, so we got the open port state, the closed port state, we got filtered port state, unfiltered port state, open and filtered, and closed and filtered. So if you want, read through this. It is really useful knowing once you get, for example, filtered port, to know exactly what that means. And if I go a little bit more down, here they are. Here are the different scan types that Nmap has. So here is the TCP SYN scan that we performed, which is -SS. Here is the -ST, which is full TCP connection scan. And down here you will notice, after the UDP scan, that we got different options as to how we can perform our scan. And you can read about each and every one of them and see when are they useful and how you can specify them. Here is the TCP ACK scan, here's the TCP window scan, and you will see there are a lot of them. There are also different options such as this scan flags, which is custom TCP scan, but this is an advanced option and we might take a look at this later on. Here is idle scan, echo scan, let's see all the way down, IP protocol scan, FTP relay host, FTP bound scan, and that would pretty much be it for the Nmap scans. So depending on your target and what you exactly want to get from this scan, you would pick one of them. So for example, if you wanted to discover open ports, you would use the TCP SYN scan. Now the ACK scan, I believe, which is the -SA, which we saw a few seconds ago, is useful, I believe, to mapping out the firewall. Just read through them if you have time, and you will discover how they work and when are they useful. So let's see how much percentage our UDP scan is at. So it has finished about 1/3 of the scan, and we know that this will take at least 10 to 15 more minutes, so we're not going to wait this. And by the way, about the Nmap manual, you don't need to read that entire file, just it is good to know that it exists. So sometimes when you forget something or you want to check out if Nmap has some other option that you need, you can just open that manual and read until you find what you need. Nobody expects you to know everything inside of that file, but after some time you will start picking some of the commands up and memorizing them. Cool. We covered a lot in this video. The next 2 videos will be even more important. We're going to check how we can discover operating systems that our target machines run, and what versions of services are they running on an open port. Which is, remember, one of the most important things that we want to find. Let us check out how we can figure out what operating system is our target running just by scanning it with Nmap. In Nmap, this feature is quite popular, as they have a database of thousands of known operating system fingerprints that they compare with the host that you scan in order to find out what operating system is it running. But for this to work, a target machine must have at least 1 port open and 1 port closed, which we need not to worry about since our Metasploitable has both open and closed ports. However, it could not work for some other targets. What I'm going to do in this video is I'm going to try to scan my Metasploitable, which is running Linux, and then I will try to scan my Windows 7 virtual machine that I got right here, and I will try to scan my Windows 10 host machine. And let us see what results can we get. Let's see whether Nmap can figure out what operating systems are they running. If I go back to my Kali Linux, and let's go with Metasploitable first. To run the operating system feature, we must use sudo, and after Nmap we specify -o for discovery of operating system. Then we specify the IP address, and if I specify the IP address of my Metasploitable first, press enter, type in my password. It will take just a few seconds, and down in the results we can see the OS testing, it tells us right here that Metasploitable is running Linux. And down here in the OS details, it tells us which version exactly is it running and how many hops is the target distance from us. It says 1, which means host is inside of our network. And besides all of this, it also tells us that the machine that we are scanning is a virtual machine, as we can see right here. It managed to figure this out by the MAC address that Metasploitable has, since VirtualBox machines have MAC addresses that start the same. And these are these 3 first numbers. This is really interesting because it can sometimes help us to realize that our target is an actual virtual machine and not a physical machine, which could possibly indicate that we're scanning a honeypot, which is usually a purposely vulnerable virtual environment that is used to lure in hackers in order to find out whether they're being attacked. This is because usually an attacker will go for the most vulnerable machine first, and that's how they catch him. That vulnerable machine could possibly be put there on purpose. So for our Metasploitable, we got the correct result. It tells us that it is running Linux, which is correct. Down here it even tells us which version of Linux is it running. And we can also see right here by the MAC address that this is a virtual machine. So we got a lot of useful results for Metasploitable. Let's try with my Windows 10 physical machine. So if I type sudo nmap-o, and to scan my physical machine, I must check the IP address inside of my command prompt. If I type ipconfig, it will tell me that my IP address is 192.168.1.7. Let us type it in, 192.168.1.7. And run this scan. It should also take just a few seconds. Once again, you can check at what percentage is it at by pressing the upper arrow key, and it is currently 81% done, so let's just wait for the remaining few seconds to finish. And it will tell me right here that it didn't manage to discover OS details. Now why is that? Well, because we can see right here all 1000 scanned ports are either closed or filtered. And remember, to discover an operating system, we need at least one open port and one closed port. In this case, there is really nothing that we can do to discover operating system with Nmap, since all ports seem to be filtered. Let's try the same of Windows 7 virtual machine. I know for a fact that the Windows 7 virtual machine has one port open, so let's see whether it will manage to figure out the operating system on that machine. If I type sudo nmap-o, and I already typed ipconfig in my Windows 7, the IP address is 192.168.1.14. Let's specify it right here. Let's wait for this to finish. And it gives us a bunch of OS details. Up here we have a warning that says, results may be unreliable because we could not find at least one open port and one closed port. It did manage to, however, find one open port, which is this port 445, but all the other ports are filtered. However, based on this one open port, it tried to guess what operating system it has, and it was relatively close. It managed to guess that the operating system is Windows, and sometimes this could be enough for us. We can see right here it specified Windows 7, which is correct, but it also specified Windows Vista and Windows 2008, which are incorrect guesses. So we can say that it managed to narrow it down for us, but it didn't really hit the correct one. So we checked how to figure out what operating system is the target running. We noticed that it doesn't always work, but this information, with the information which we will get in the next video, will be more than enough for us to be able to conduct a vulnerability analysis. Let us see in the next video how to get exact version of services running on open ports. Welcome back. Let us finally check out how we can figure out the version of software running on an open port. For now, we managed to discover open ports. We also learned what different scans do and which ones are better to use. And we learned how we can identify an operating system on some of the targets that we scan. Now, let's see one of the most important parts that will also help us in identifying vulnerabilities. So, why do we care about versions of software so much? For example, I might somehow find out that Metasploitable is running Apache web server on port 80. But that doesn't narrow all the possible attacks too much. Of course, it narrows it down to only search for Apache vulnerabilities, but Nmap can even go as far as discovering what exact version of Apache is it running. Then, after knowing the version, we can search that version on internet and try to see whether there are any known vulnerabilities for that specific version. So version discovery helps us a lot. And let's see how we can perform it. To perform version discovery, we use the option -sv. So I will run the command nmap -sv, and as usual, we're going to be scanning our Metasploitable. Now, this command also requires sudo privileges, so make sure to type it at the beginning of the command. Sudo nmap -sv and then the IP address. Press enter, enter the password. This particular scan could take longer than other scans, because right now we are deeply scanning the target. Let us check out at what percentage is it at. So 91%, it should finish in just a few seconds. Let's wait for it. And here it is. We can see we got a bunch of result right here. The new thing that we got from all the previous scans is this fourth column. Remember, once we scanned previously, we only got these first three columns, which are the port number, the state of the port, and the service that it is running. Right now, we also get the version of the service. So let's go quickly through this. We got port 21, which is FTP, and right here we got the exact version of what type of FTP software does it have. For the SSH, we get the same thing, so the version of SSH is OpenSSH 4.7, Debian Ubuntu. We got the Telnet, the SMTP, the HTTP, we got that it is running the Apache HTTP 2.2.8. For the SMB protocol, which is port 445 and 139, we got that it is running Samba from the 3 point something to 4 point something. In this range will be the version that it is running. What we would do with this information, as I already mentioned, is we would just try to search for some known vulnerabilities for the specified versions. For example, if this Apache version right here has a known vulnerability, we would discover it by pasting this in Google and typing vulnerabilities. And whatever comes up, we would test this on this target and see whether it works or not. Since some vulnerabilities could be patched. We never know, so we want to try it out. Down here we also got the versions for the other ports, so we get a bunch of results right here. What you would do with this scan, since this is really useful, we would type this on a report and we would use for the future references. For now, let me show you another option that you can use with the version scan, and that option is intensity of scanning versions. We can type it like this. So if I use the same command, let me just clear the screen so we can see it better. If I use the same command and after -sv I type version -intensity, and after the version intensity we need to specify how high we want the intensity to be. And it can be set between 0 and 9. The default one, which we used in the last scan, is 7. So every time you don't specify this option, it will be 7 by default. If we set it all the way up to 9, then we will have higher possibility of identifying the correct service version. However, in 99% of Nmap scans, this option is not needed. You can just leave it on default, which is 7. If you set it at 9, it will take longer time, and since we're scanning a target that is on our own network, it will still do it in just a few seconds or minutes. But if you were to scan a real target, Nmap scans could take a lot more time to accomplish. So you always want to consider not only performing most accurate scan possible, but also performing a scan that will be equally fast and accurate. So sometimes we have to lose one thing in order to gain the other. That would be pretty much all for the version scanning. Now, we're not going to be running this command since I can tell you right now that it will give us the same output as the previous one. So in this case, increasing the version intensity won't help us too much. And as far as these options go, there are more options for the version discovery that you can check out inside of the Nmap manual. But before I end this video, I want to show you another thing that I also use a lot, and that is the -A option. So let me show you right here. If instead of all of this I specify -A, and -A is so-called aggressive option. It enables some advanced features of Nmap. Those advanced features are, well, first it enables OS detection without specifying the -O that we already covered. It also enables the version detection without specifying the -SV. And it enables something called Nmap script scanning. What Nmap scripts are something that we will cover shortly. For now, just remember that -A enables all of those things that we covered in the previous videos, including Nmap scripts. And since -A is one of the more aggressive Nmap options, please do not try this on targets that you do not have permission to scan. However, let us test it out on our Metasploitable target, and if you want, you can also try to scan your home network with it. Just keep in mind that since it is using all of these options, it will take some time, even if it is scanning our home network. So, if I run this command, this will take some time. If I press upper arrow, it is 78% done. And the output of this option we're going to see in the next video, as well as some other useful things that we can do with Nmap. As soon as we check that, we are going to get into firewall evasion using Nmap. See you there. By now, if you covered all of the Nmap videos that we did, you should have an intermediate knowledge of Nmap. All we are left to do to check out is just some of the few options that you might find useful once you're performing your scans, which we will check out in this video. And after it, we need to check out two more things. One of them is running Nmap with scripts, which part of it we're going to see right now with the results of our -A scan from the previous video. And the second thing is how we can bypass firewall, IDS and IPS using Nmap. So for now we only noticed how we can perform different scans, but we never really talked about what if our target is well secured, what if they have a firewall. We want to perform our scans as quietly as possible in order for us to not get detected. But before we jump into all of that, let us check out the output of our -A option. Remember from the previous video, -A runs a bunch of different things such as OS detection, version scan, and it also runs something called Nmap scripts. You will see down here that we are getting output that we didn't get before. So besides the open port and the version that the open port is running, we also get the output of different scripts that are running on the target as we execute this scan. So right now, here we can see that it executed the script for FTP anonymous login, and it says that it is allowed. And we will check out what the FTP anonymous login is. For now on, I can tell you that it is not really that secure. Even though if we go all the way down, here it says FTPD 2.3.4, which is this version that the target has, is secure, fast and stable. And I can assure you this is one big lie, as this FTP version is vulnerable. And we're going to see in the exploitation section how we can exploit this and gain access to our target machine. Down here we also get the enumeration of the SSH, so we get the SSH host key, nothing really too useful for us, the SMTP commands that are allowed, the SSL ciphers right here. We also get the HTTP server header, the HTTP title, and these are just some additional information that we got from running scripts. If I go all the way down, we also get information for some other open ports. And down here, we will see that our scan also performed the SMB enumeration. So we got the computer name, NetBIOS computer name, domain name, SMB security mode. Down here, we also get the trace route to this target's IP address, and this is the one hop that we have since it is in our own network. It tells us down here that it also performed the OS and service detection, and here is the OS detection, but we already saw this. We got Linux running. So this is just some additional information on top of the information that we already had. But remember, -A is an aggressive scan. It does give us the most output out of any other options, but it is also pretty aggressive and easily detectable, if target has some security measures. Since our Metasploitable doesn't have any security measures or is not behind any firewall, this scan is best for targets like that. So we got the most information using -A. But besides this -A, let us also check a few more useful options that Nmap gives us. And to do that, we're going to run the Nmap manual. So type man and then Nmap, and it will open up the manual once again. We already know how we can go through it with upper and lower arrow. And we're going to just go really quick through it and see whether there are any useful options that we haven't covered, but that you might want to use. So if we go down here, this -SN option is really useful option. And it is not really useful for discovering vulnerabilities or open ports. Matter of fact, this option right here performs the same thing that our NetDiscover tool did. Remember, we use NetDiscover to locate all of the hosts that are up and running on our network, and -SN pretty much does the same thing. As we can see right here, this option tells Nmap not to do a port scan, so you will not find out any open ports with this scan. The only useful thing we get from this is which hosts are up and running. So let's test it out real quick. And this is a scan that you would use probably on multiple machines to discover which ones are up and which ones aren't, but you can also use it on one machine if you'd like. For this scan, I will use my home network, so -SN and then 192.168.1.1-255. If I press enter, this should pretty much in just a few seconds, and here it is, it will give us which hosts are currently up. We get their IP addresses, so 192.168.1.10, this is my laptop. We get the Metasploitable, we get Windows 10 probably, and we get my router. So instead of NetDiscover, you can use this to figure out which hosts are up. But for me personally, I like NetDiscover output a little bit better than this one. This right here looks a little bit messy. Okay, so the second thing that I want to show you is -P option. And this is an actual option that you will use a lot. So for this, we're going to scan our Metasploitable, so change the IP address to the Metasploitable IP address. And what -P option is simply you can specify what range of port you want to scan with Nmap. So remember, when we perform any other scan, it scans top 1000 ports. But what if we, for example, only wanted to scan one port? For example, let's say we wanted to scan port 80 on the Metasploitable. Can we do that? Well, if you specify -P and then 80, and then the IP address, here it will tell us port 80 open and service that it is running. So we can scan only one port if we want. This option is useful if you're only attacking one port and you don't want to bother really and let Nmap scan 1000 port when you only want to enumerate one single port. You can also do it on multiple ports, for example port 80, port 22, port 100, and let's see what the output is. And here we can see port 80 and port 22 are open, while the port 100 is closed. We separate different ports with comma, and instead of separating them with comma, if you want to scan a range of ports, you can also do this. You can do port 1 to port 100. And here are the results. Not shown, 94 closed ports, and we got 6 ports that are open in first 100 ports. And remember when I told you that there are over 65,000 ports? Well, this is the option that we can use in order to scan all 65,000. If I type the same command, just I scan from 1 to 65,535 and press enter, this scan will take longer than any previous scan that we did, since it is scanning 65,000 ports. Here we can see the output, it finished in 7.74 seconds, and here are all the open ports that it managed to discover. Here are some of the ports that we never really discovered with previous scans that we did in last few videos. So this is really useful. If we used regular scans and we only scanned first 1000 ports, we would never really know that these ports are also open. Now, on the contrary, instead of scanning 1000 ports or 65,000 ports, we can use a cool option, which is -F, and it is capital F. And what this option does is, instead of scanning 1000 ports, it scans first 100 ports. So in case you want to perform a quicker scan, and you also want to scan top 100 used ports, you would use the -F option. If I press enter, you can see it finished in less than 1 second, and it scanned top 100 ports. Now this doesn't mean that it scanned port from 1 to 100, this simply means it scanned first 100 ports that are usually most used. So we got 21, 22, 25, 53, and a bunch of others as well. But whenever you really want to find out everything you can about the target, this scan will be more useful. The one where we scan 65,000 ports, since you can see there are a lot more ports that are open than with this scan. Okay, cool. Let me show you one more option before we proceed to the next video. And that option is how to output an Nmap scan. So there are a few ways that we can do that. If I run Nmap and then we use the SceneScan, which we covered, and let's say we scan the Metasploitable, there are two ways that we can do this. If we want the output to be inside of a file, we can use two arrows to the right and then output of scan.txt. Let me see, you requested the scan type which requires root privileges, so let us run it with root. And press enter, type in password, and you will see we get no output to our terminal. That is because all of the output is stored in this file. If we use the cat command to output the results, here is our scan that is being stored inside of this file. So this is useful once you want to, for example, add this to your report, so you just save it in a file and then later on copy and paste this on a report. Another way that you can do this, in case you want the results to be saved both in a file and also outputted in your terminal, we can use the -on option. So -on, I'm not sure if it is with capital N or lowercase n. We're going to check that out with the help menu. So let's go to the output settings, and it is -on option. And we can see right here -on option is output scan in normal. So we can simply just save this in a normal file. If you want some other file type, you can use OX for the XML. And we got some other options here as well that you might find interesting. For now on, we're just going to check out this one. So if I go down here and type nmap -on and then -ss, of course we need to run this with sudo. And we specify 192.168.1.5. Output file begins with, we need to specify the name of the file that we want to save it, so let's just call it output. And here it is, we get the output to our terminal, but if I also type ls and cat the output file, we also get the results saved inside of this file. Okay, great. These are just some of the basic options that I wanted to mention, since you might find them useful. And by now, as I already told you, you can consider yourself an intermediate Nmap scanner. Now to take this to the advanced level, we're going to check out in the next few videos how we can bypass firewall, IDS and IPS using Nmap scans. In this small section, we're going to cover how we can use Nmap in our advantage to be able to bypass some of the security measures that the target might have, such as firewalls and IDS. These options that we will use in Nmap can be considered advanced, so don't worry if you don't fully understand everything that we talked about in next few videos. Just make sure that in case there is something that you didn't understand, rewatch a video a few times and you will get it. But wait, Alexa, I don't even know what firewall or IDS is. So what are they? Well, firewall is a network security system that monitors network traffic, and it is based on the security rules that are predetermined. There are two types of firewalls: network firewalls and host-based firewalls. Network firewalls filter traffic between two or more networks, while host-based firewalls only filter traffic that is going in or out from that specific machine. And what IDS is intrusion detection system. It is usually a software application that monitors the network for any malicious activity. For example, some of the Nmap scans that we did in the previous section, can get caught by intrusion detection system. So in this section, we will check out a few options that could help us bypass that. All in all, firewall and IDS helps us secure our network or machine. In the previous section, where we covered Nmap basics, we used our Kali Linux machine and we scanned our Metasploitable target. We scanned different ports, and with the scans that we did, we managed to figure out what ports are open and what ports are closed. But some of our targets might host services on ports hiding behind the firewall. And once we scan them, it will tell us those ports are filtered, which we know that it means Nmap can't figure out whether that port is open or closed. What this means is that we're sending packets to that target, but their firewall keeps dropping those packets. And in this section, we're going to see what Nmap options can help us in bypassing this. Let's get straight into it.